The title of this module is the motivation and the software crisis. This module is broken up into three parts. The first part, this part, I will be discussing the problems we are facing in the software industry. The next part, I will discuss kind of the main challenge we are facing, our ability to manage complexity. And then in the third part, I discuss how complexity is managed in other types of systems as a way to gain some insight into how we can also manage complexity within software systems. So all of us that are in the software industry probably had our own reasons for getting in here, and they're probably reasons that tend to make us happy. I recall meeting one of my first friends after getting out of college who was a software engineer at McDonnell Douglas, and I asked him why he got into software, and it was because he enjoyed the fact that software provides you an immediate return on your effort and investment. You program something, you run it, you can see it working, and that was a very powerful experience for him. You may have that reason as one of your reasons, but there's probably others as well. Many people are driven to kind of innovate, and some people just want to kind of solve problems in our world that can be solved through software. Some people are doing it just for monetary reasons. Whatever it is, those reasons that got you in here are positive reasons and things that would make you happy. The problem is, if you've been in this industry long enough, you've had a bit of a reality check. Any one of these quotes here probably resonates with you and your experience in the past, everywhere from that may seem like a small change, but, or this is a classic. If you ever had to get into a system and try to make a change, you knew you had to make a change to one part of the system, but the person who was helping you out says, no, it's going to have to be Jeff or George or Lisa because they're the only ones who know how that code works. Or how about this one where it's the business folks might come and ask you for a big change, and you've been maintaining the system for years, and finally you kind of throw up your hands and say, well, if we're going to do that, if we're going to make this change, we might as well just rewrite the whole thing, but of course we'll do it right this time. So unfortunately, with software development, it comes with a lot of pain, as well as some of the upside that brought us in here in the first place. And this pain can come in a lot of different forms, and all this stuff is, by and large, self-inflicted. Back in 2011, Mark Andreessen wrote an interesting essay on why software is eating the world. And his point in this, it was not despite the title, it was not a negative article. It was a recognition that software is playing such an increasingly large part of our lives in terms of really being invading or even being a major part of pretty much every industry today. Many industries have transformed from traditional manufacturing to relying, or in other types of industry, to relying heavily on software, and software sometimes even becoming their main product. So there's really not an industry out there now that is not either building software as a product or heavily leveraging software to give them some sort of competitive advantage in their field. The problem is, along with this great opportunity that software presents us today, is a reminder of all the problems we have with being able to build software systems that people can rely on. I've collected articles over the years of various software fails, but you can hardly go a week really these days without seeing something that is causing problems. Who can forget Healthcaregov back when that first came out and the marketplace first opened up, and all of the problems that occurred. Who could have guessed, tongue in cheek, that millions of people were going to want to sign up for healthcare who didn't have access to healthcare before. So it's not like this should have caught them off guard. In fact, 6 months before the healthcare.gov system went online in October of 2013, a internal review recognized that there was significant deviations from usual IT standards in the way the system was designed and built. So they already knew that there was problems along the way. And there's a famous quote by Mark Zuckerberg back in the day who prior to 2014, where he stood in front of the F8 developer conference and said, we at Facebook, we're all about innovation. I tell my people to move fast and break things. Very famous quote. And I see that on posters on people's walls even to today. What those people probably don't realize is that back in 2014, Mark Zuckerberg, backed away from that statement quite a bit when Facebook was faced with a variety of different quality issues within their platform. They realized that just going kind of haphazard, developing new features and not worrying about quality was inhibiting their ability to really move the platform forward. So his new mantra is at the bottom there: we had to slow down to fix these bugs. It wasn't improving our speed. So it's like move fast, but be careful and don't break anything. Even in our last election, we had issues with software around the potential of the Russian entities compromising our election through some sort of hacking of software-based election systems or email platforms or whatnot. Within the last 2 years, Wells Fargo inadvertently foreclosed on homes because of a software glitch. Here, just last December, Boeing Starliner spacecraft, they nearly lost this spacecraft on a main test because there was an issue with the software, and they hadn't really done enough testing to really uncover that before that launch. Fortunately, they were able to make some changes in flight to avoid completely losing the vehicle, but the test itself was, did not achieve any of the goals of what they were looking for. And wow, just within this year, a seemingly straightforward mobile app for helping to tally the Democratic caucus in Iowa was just an epic failure. And this is embarrassing. This is embarrassing to us as an industry. Every time something like this happens, it makes national news. I am personally embarrassed. And so it's not good when we see this stuff happening, because people get an impression that, software is unreliable and this profession doesn't really care about creating quality work. Back in 2017, an article came out in the Atlantic called "The Coming Software Apocalypse," and really what it was foreshadowing was this idea that software was becoming such a major part of our lives, and yet we seemed ill-prepared to really manage that complexity. They gave, in one part of the article, they were talking about systems that we rely on being unreliable, and there was one day, I don't remember the exact year, there was one day where on the same day the 911 system went down in a particular part of the country. There was one of the trading platforms in New York had to be taken offline because of it was having problems, and air traffic control systems were also suffering from that day. And literally people were starting to wonder whether or not we were under some sort of coordinated cyber attack on that day. Almost, and the quote here from the article, almost more frightening was the realization late in the day that it was just a coincidence. It just so happened that those three poorly designed systems were failing on the same day. So why is this still happening? We have to ask us this, because certainly over the last 20 years, we have really evolved and matured our process around requirements management. We've started adapting agile and lean practices. Quality assurance and the ability to do various types of testing seems to have increased. Our ability to collect metrics, either manually or automatically through our cloud-hosted systems, our technology platforms available to us have matured tremendously, and yet we're still suffering. Well, one thing we need to recognize is that systems are getting more and more complex and more integrated into our lives and businesses. So this is a great time to be a software developer, much like what Mark Andreessen was talking about with software eating the world. But we seem very ill-prepared as an industry to meet this challenge. There's a group called the Standish Group that over the last 25 years has collected a lot of evidence that points to our inability to kind of meet this challenge. So this is back in 1992, and out of what they call their chaos report, where they monitor the quality and effectiveness of software projects and their ability to kind of be completed under successfully. So back in 1992, only 16% of software projects were on time and on budget. Another 53% were late and over budget, and then a full third of the projects were canceled. Well, in 2017, that same report showed some improvement, but still we have a fifth of our projects that are outright canceled and more than half that are either late or over budget. So while we've made some progress, I would judge this progress as still insufficient. There's all kinds of other evidence too. This is from Applied Software Measurement from Capers-Jones back in 2008, and these numbers really haven't changed much over the years. Only 15% of companies improving productivity and quality. That might be good, except for the fact that 15% of the companies are getting worse. And there is certainly a gap between those organizations that are high performers in the field. Evidence shows that the high performing mature companies are often 3 times better than the average companies. That's a significant differentiator and a significant advantage that a company or an organization would have to have that kind of maturity and that kind of high performance. The CMMI Institute that was born out of Carnegie Mellon, which has a program for tracking and certifying certain maturity within software development processes. They collect a lot of data about the companies they work with. Here we see only 50% of companies, 50% of companies don't have standard processes, process assets, and job aids. 42%, no established planning process for their projects. 54% at the bottom there don't measure what matters. So more than half the people don't have metrics that really help them improve the processes that they do have. 33, a third of them cite difficulties in monitoring plans and making adjustments when needed. So here you start a project, and we all know projects change along the way. Yet a third of the companies out there say, well, that change happens. We don't really know that change happens. And even if we do know, we can't really make adjustments to kind of get projects back on track. A full third of the companies out there that are monitored. Once again, from Capers-Jones, that almost 50% sometimes of software effort devoted to defect removal. So we're spending sometimes half of our time not really adding value to the product, but just fixing what we'd previously done, either because of bugs, because of poor requirements, whatever it is. There's multiple sources for this. Sometimes he noted that sometimes it's not a bug or poor requirement. It's the fact that the architecture or the code was not designed to accommodate changes. And that's going to be a major theme within this course, is how we actually tackle both these things. Both how do we specify requirements or identify requirements more clearly, but also how do we design systems that can accommodate change. Quality processes still remain a challenge. So despite agile adoption, almost 100% say they continue to have difficulties testing in an agile environment development. That to me feels like a total fail. If we're adopting agile and certainly agile testing is a major component of agile processes, and yet 100% of people saying, hey, we're having problems with that. Even down here on continuous testing and continuous integration, less than half of organizations are currently using it. Now, a lot of them are planning to use it, but less than half are currently using tools and technologies that have been probably considered best practice for, I would say, going on a decade. So you can imagine the business leaders and stakeholders that we're working with have got to be incredibly frustrated, right? They're constantly hearing from us that, well, the project's late. Well, it doesn't quite meet what the customers needed. Once they got into using it, they realized that it needed something different. I mean, I think we can understand the frustration that the people that depend on us to develop software are probably having. And I know I myself have asked this question. When I got into this industry back in 1995, after being a systems engineer for 8 years, and seeing what I would consider to be the chaos of commercial software development, over the course of the next 5 or 6 years, I started wondering: is this just the nature of software? Is software just not something that can be engineered, if you will, which is more about my background? Well, it's easy for us to find failures in software, but I think if we keep our eyes open, we can also see there are tremendous examples of successes in software. And the one I like to point to the most is the Mars Curiosity lander. If you've never watched the 7 Seconds of Terror or 7 Minutes of Terror YouTube, which shows the JPL team out there that was waiting patiently for telemetry data to come back as the Mars Curiosity rover, which is the size of a car, was successfully landed on Mars autonomously. The amount of software and software testing that had to go into that is tremendous, because there was no way for them to simulate that sort of a landing here on Earth. Or every time I see some of the Falcon reusable boosters landing after a launch, I almost feel like it's a visual effects of some sorts. So there's plenty of examples of software systems that have been built. You go and look at the aircraft flight control systems and things like that. Now, Boeing has some issue with some of their software now, but by and large, aircraft are incredibly safe, and they're all being run by software. So we know how to build robust systems. We know how to design software that is incredibly complex and incredibly reliable. There is a way to do it. But our problem is we have, by and large, the commercial software industry is plagued with what I would call poor software engineering literacy, just not knowing even what we don't know. And there's one report here that was, one study was put together to try to figure out at what point during software development are a lot of the poor code practices or code smells injected into the software. And what they found, oddly, was that rather than having code smells occur during the lifetime of a piece of software, many of those code smells were actually built in from the very first version. So our ability to just start with a good design, start with a good architecture is often compromised by our inability to really know how do we actually manage the design and development of these systems. So that's a bit of an overview of kind of the crisis that we're facing, and a lot of data that supports that. In the next part two of this, we'll dive in more deeply about this challenge of managing complexity.